Good morning, everybody. Thanks for joining us today. I hope you're well. My name's Katie and I'm the course coordinator at the National Self-Build and Renovation Centre, and I'm going to be facilitating on a session. So I'd like to welcome everyone today to the Passivhaus and REBA 2030 Climate Challenge presented by Anna Carton from Passivhaus Homes. Before we begin, I'd like to point out a couple of functions that we've got on Zoom so that you can interact with us today, although I'm sure quite a few of you will be familiar with these now if you've joined us for previous sessions. So if at any point you'd like to ask Anna a question, please use the question and answer function below, and we will have a short amount of time dedicated at the end of Anna's session for her to answer your questions. But please remember, if we don't get around to answering your question, we do have a 3 p.m. session today that is dedicated purely to answering your questions throughout the day. I'd also like to mention before we begin that these sessions are being recorded and you will receive a link shortly afterwards via an email. And that's about all from me for now. So I think I will hand over to Anna, and without further ado, we'll get the session started. So over to you, Anna. Thank you very much.
Great, thanks very much, Katie. I'm just going to share screen. Hopefully I get this right. I'm hoping that you can all see the presentation. So thanks very much, and thanks for the opportunity to talk today. I think you've all just had Chris Herring's session on introduction to Passivhaus, so I'm going to assume that you're all now experts on that. And I'm going to be talking about Passivhaus and the ROBA 2030 Climate Challenge to sort of discuss how Passivhaus might fit into that challenge as we drive towards net zero carbon in all new buildings by 2030. And the aim is to be net zero carbon in all buildings by 2050. Just to give a bit of background on me, I work for a company called called Passivhaus Homes. We supply a whole building solution for achieving passive house in your buildings. So basically deals with all the fabric and the airtightness of the ventilation system. And I have been working with Passivhaus design for about 10 years. But more recently looking at sort of the embodied carbon sort of side of it. So I'm going to start my presentation today by asking you all to ask a question of yourselves, really, which is what's important or what makes up a sustainable building in light of the climate emergency and also the targets for 2030 and 2050. And the wheel that's on the screen is actually one that came about through a discussion with a number of other sustainable building designers, architects, who have all worked in this field for over a decade, some people over 25 years. And all of us Passivhaus designers and all of us were in agreement that we should be focusing our energies on targeting operational energy, which is obviously the Passivhaus element, but Passivhaus also spills into what you choose to build with, and also now with Passivhaus Plus and Passivhaus Premium, the renewable fuel sources that you choose to run that building. In our wheel, we've also got other things that you might think are outside of sustainability. You might think design is outside sustainability, but obviously we're going to look after the buildings that we appreciate aesthetically. So things like this are also important and might be in your wheel. Other things might be biodiversity, community, economics, etc. So I sort of wanted to just invite everybody to think about what would go into their wheel. The other thing I wanted to raise at the start of this presentation, or to sort of show you, is this this bar chart by Greenlight Energy Assessors, and this sort of highlights three things really. The first thing is that buildings are perhaps the longest lasting physical things that humans create. So the impact of your decisions as a building specifier or as a building designer will echo long into the future, and the impacts far-reaching. But so the second thing is that it's not just what you make the building of, but also what you put in the building, the components that will need periodically replacing. How many times will they need to be replaced over the lifetime of the building is something to think about as well. And then the third thing that this lifespan of things shows quite well, I think, is that quite obviously 2030 is really not a long time away at all. And it's certainly not a long time in the context of building cycles, how long it takes you to go from finding your site to finding a designer to actually building a project. It's a very, very short period of time. So you really need to know where we are and where we need to get to net zero carbon in just 9.5 years. So the RIBA published their climate challenge document towards the end of last year. I think it was in November. And they very helpfully provided a series of target metrics for domestic and commercial buildings, but I'm just talking about domestic buildings here. And that covers three things: operational energy, embodied carbon, and also water use. I'm not going to be talking about water use. I'm just going to be focused on operational energy and embodied carbon. So if we look at the operational energy number, it's suggesting 0 to 35 kilowatt hours per meter squared per annum by 2030. You all know from Chris's talk that the space heat demand in a passive house should be 15 kilowatt hours per meter squared per annum or less. The Committee for Climate Change have suggested that we need 15 to 20 by 2025, so in just 4.5 years, they are suggesting that we move to the Passive House standard, or certainly buildings that follow the principles of the Passive House standard, to get the space heat demand as low as we can possibly achieve. So we think on operational energy, Passive House is sort of in the zone of where the RIBA are telling us we should be, where the Committee on Climate Change are telling us we should be. This is also in line with what the Green Construction Board is saying, what the Green Building Council is saying, what RICS, the Royal Institute of Chartered Surveyors, are saying, what CIBSE, the Chartered Institute of British Service Engineers, are saying. So that's just to highlight that the industry, in terms of the designers industry, are certainly in agreement that we need to get down, get operational energy down below 35 kilowatts. In terms of embodied carbon, they've set this target of 300. And what I'm going to sort of explore in the talk today is what does that actually mean? Because the reality is that the sustainable building industry has probably been more focused on operational energy and less focused on embodied carbon up to sort of fairly recently. But now we're seeing much more focus on embodied carbon, and we're going to look at some examples in this presentation today. So embodied carbon is measured using this British standard. And if you look up an environmental product declaration certificate for some of your building products, some might not have them, but more and more companies are doing this and should be doing this. You should find within that document that they will report embodied carbon values for each of those stages of the product. So you're going from the extraction of the raw materials, the transport of those materials from the manufacturing plant, the manufacturing to site, the construction, the building use, the maintenance of that building, the repair of that building, the replacement, the refurbishment, and then finally the end of life when you take that building apart, or whether it becomes recommissioned, whether you reuse or you dispose the materials. So stage C is perhaps requires a little bit of a crystal ball, particularly if you're looking at a new building, trying to predict what might happen to that building in over 100 years, requires a little bit of many assumptions, but they can apply some figures based on today's values. So the RIBA Climate Challenge wants us to get to 300 kilograms of CO2 per metre squared across A1 to C4. So that's from taking the materials out of the ground to then disposing of the building at the end of its life. So some materials have carbon sequestration potential, materials like timber, or carbon storage potential, I should say, sorry, carbon storage potential. But you can only count those right at the end of its life. So if you have a study that looks just A1 to A5, then you cannot count the carbon storage of those materials. You can only count them at the end, for obvious reasons, at the end of the life. Passivhaus, the Passivhaus standard is directly only really interested in B6, which is operational energy use. But indirectly, because of the decisions you make of how to get there, the fact that you're looking quite closely at the building fabric, obviously indirectly then covers all the other things. So you might look at the table on the left and think B6 is just one stage of many. It looks relatively insignificant, but as the wheel on the right, which is a Simon Sturgis study, shows that it can make up a significant chunk of the whole life carbon emissions of a building. And in this case, it's about a third. In a particularly poor performing building, it might be more than that. In a better performing building, it would obviously be smaller. A way of measuring embodied carbon is, for Passivhaus buildings, there's now available is the pH ribbon, which is very easy to use. It basically takes the information that you've already put in your PHPP. So you've already got the U value on the U value sheet. You've already specified all the materials that make up the fabric of the building. And in the areas tab, you've already assigned square meterage to those materials. And then it simply applies an embodied carbon value, or you apply an embodied carbon value to those materials, and then it will do a calculation for you, and we'll look at some examples in a minute. So we know we've got to get from 1,000, which is the benchmark, or the target for today, 2020, is 600 down to 300. And now I'm just going to look at a few examples of what sort of numbers some typical domestic constructions are reaching. So if we look at traditional, this study, which is an ex-CO2 study, and it looked at traditional masonry, and it looked at SIPs, and it looked at lightweight timber. And, but it only looked, the study is a few years old, so it only looked at cradle to gate, so that's A1 to A3. So the figures we're going to see in a minute are only part of the picture. So traditional masonry is coming out at 348, SIPs is 308, and then lightweight timber, which we actually adjusted their figures slightly to make all three options have a concrete slab and footings, is 231. So already we can see that there may be a problem with the traditional masonry that they have looked at, because we seem to be failing, and we haven't even got to site yet. The same with SIPs. Lightweight timber is coming in under the 2030 climate challenge target, but again, we're not even at site yet. So certainly this 300 target is starting to look relatively challenging. If you take the slab out, which is a significant portion of the embodied carbon, and you look at the building just above ground, now you can start to see the real significant difference of the three different construction options. There's a fourfold difference between the lightweight timber option and the traditional masonry option. And that's simply because masonry is just high embodied, it's heavy weight, and also high embodied carbon. There is no carbon storage in these calculations because it's only A1 to A3. If we look at some examples from pH Ribbon, so these examples are available, done by Tim Martell, who wrote pH Ribbon, available on his website. So he looked at a detached house in Hampshire, and he looked at two construction options. One is timber and PIR, and then the other one is the same house but as cavity wall. And this bar chart might look a little bit confusing because it looks like there's more emissions but also more savings on the option on the left. So how do you really compare them? But if you take out the savings from the emissions, it's sort of more obvious to see that the timber and PR option is emitting less carbon than the cavity wall option. And in this example, which is cradle to grave, so it's A to C, the timber and PR option is just passing, and the cavity wall is not. And the highest contributors in each example is obviously the timber and the oil-based insulations. Oil-based insulations are quite high in terms of imported carbon. And then again, it's a huge amount of concrete for heavyweight structures is needed, and also the brick in the cavity wall option. Here is another example, also done by Tim Martell. So here he's looking at a timber frame terrace house with brick cladding. So obviously it has the advantage of only having an exterior envelope on two faces. And in this example, we're not quite getting to the 300. We're at 311. And again, we've got the highest contributing materials are concrete and brick. Here is an example. Here is a calculation done with pH ribbon for Ruth Butler's Passivhaus. This is from an article in the Passivhaus Plus magazine, which some of you may have seen. And Ruth's house is just coming in under 300 because you've got around 600 kilograms of CO2 emitted and just over 300 stored. So that's a total of just under 300 overall. And again, so this is a CLT, I believe it's a CLT construction with oil-based insulations, and you might notice that oil-based insulations are quite a significant element in terms of the fabric emissions. So unsurprisingly, perhaps the Committee on Climate Change have identified that timber will be key to, they describe it as key to displacing high carbon materials such as cement and steel, and one of the most effective ways of using limited biomass resources to mitigate climate change. They want the UK to increase timber frame construction systems tenfold in order to triple the amount of carbon stored in UK homes. Just before we go back to operational carbon, I just want to sort of summarise that what we've just looked at, which is to say that this target of 300 kilograms of CO2 looks quite challenging to achieve, and it looks particularly challenging or even unachievable with more typical ways of constructing in this country, which is sort of cavity wall, heavyweight, lots of concrete, lots of massive masonry materials. So if we go back to operational carbon, which I said is where we've sort of been focused as sustainable building designers and where we perhaps feel that we're doing better, we know that Passivhaus is 15 kilowatt hours of space heat demand. So we've got 20 left for all of our electrics, etc. So how are we doing? Well, we looked at this number in the context of one of our projects. This is a PH15 project down near the New Forest. It's a detached house. It's quite a large detached house. It's 184 square meters of treated floor area. It's got a very low space heat demand. It did incredibly well on the air tightness, so it's a very low space heat demand. It has a small PV array, and at the moment it has a gas boiler for heating and hot water. The client had wanted to go for an air source heat pump, but it was slightly out of their budget. So the idea is that they have a gas boiler for now, and then spend the next few years saving up for an air source heat pump and retrofit that in as soon as they're able. So we looked at this house in terms of its current setup, which is basically a Passivhaus Classic, so it's a gas boiler and a small PV array. We then, a different option for Passivhaus Classic might be electric off-grid heating and hot water, and then what they want to move to, which is a Passivhaus Plus, air source heat pump, and the same PV array. So the Passivhaus Classic options without the PV are not meeting the operational energy targets, the RIBA operational energy targets for the 2030 climate challenge. With the PV array they are, but by far the best performing, unsurprisingly, by far the best performing option is the air source heat pump, where you are obviously getting more, you know, if you have a COP of 2, you're getting more, twice the amount of energy out that you put in. If you convert, because obviously the operational energy is looking at kilowatt hours, the embodied energy is looking at kilograms of CO2. So if we try and create some kind of comparison, we need to convert the operational energy into carbon. So if we apply a carbon intensity to these two forms of energy, gas and electricity, the difference becomes even starker. So you apply that over a lifetime of 60 years, and you're looking at 65 tons of carbon over 60 years if you have a gas boiler, and just 12 if you have an air source heat pump. So that's an extra 53 tons of carbon over the 60-year lifetime. And that's just the difference between going, if you choose a Passivhaus Classic building versus a Passivhaus Plus, and obviously if you use a Passivhaus Premium, then that's going to be better. And the reason for that is that the carbon intensity of electricity has come down massively in the last 10 years. This graph is courtesy of Etude, and they told me that the drop is to do with the closing of a couple of coal-fired power plants. So if anyone was in any doubt of the impact of coal power plants, I think this graph highlights what a difference it can make if we move towards clean energy. There's obviously also been a drive towards much more wind-driven power in the UK, and eventually there will probably be more nuclear power coming in as well. So gas obviously is fixed. The carbon intensity of burning gas is fixed. So last year you might have read in the press lots of headlines like gas is dead and no more gas in new buildings. And this is the reason why the electricity is the future for heating and hot water in domestic buildings. So if we go back to the question of the sort of the wheel at the beginning and the balance of us looking at operational energy and embodied energy and where we should be putting our own, where we should be putting our energies as designers. So we apply the XCO2 figures to the this PH15 house. It's of a similar size. The XCO2 study was 160 square meter house. This is 180. So we did a slight adjustment, and we got 37 tons of CO2. The masonry example in the XCO2 study was around 55 tons of CO2. So it's a sort of 2/3 of a masonry. But bear in mind this, again, this is only A1 to A3. And what we're looking to do as a company is to use PH Ribbon to do A to C studies on all of our buildings in the future. Sorry, just a sidetrack. I can see questions are coming in or notes are coming in. I'll hopefully try and deal with those at the end. So we know on the embodied side, there's 37 tons being emitted cradle to gate. On the operational side, well, that depends on your fuel. If you go with gas, you're looking at the 65 tons, which we talked about. If you're looking at air source heat pump, you're looking at 12. So relative impact is obviously directly not just affected by your fabric and the demand, the heat demand of your building, but also the fuel choice that you select for your building. If you went with a building reg standard building, that's probably about 10 times what this house was, perhaps even slightly more than that. So you can see that relative to the embodied carbon, if you're looking at 10 times amount of operational carbon, suddenly that B6 in that life cycle assessment is looking relatively very, very important. And I think that just sort of goes to highlight why we've been focused over the last 10 years on getting operational energy down. To look at those results in a slightly different way, this is an illustrative graph. It doesn't factor in fluctuations in the intensity of fuels. I've sort of included one replacement of components, but the point is to illustrate that if you have those two options, the gas option, the air source heat pump, you can see them diverging across the first 15 years of that building. And then if the clients replace their gas boiler with a air source heat pump after 15 years, that gap will just be maintained. You'll never make back that carbon expenditure. The other thing that this, I'm using this to illustrate, is that if we have 10 years to not just to get to the 2030 net zero target, but also address the climate emergency, if the next 10 years are critical, the decisions you make about the amount of carbon you're going to pump into the atmosphere as the result of the materials you specify starts to look very, very significant. The carbon over the next 30 years in this example, because it's a low energy building, is significantly smaller, but also if the next 10 years are critical, and the consensus generally is that they are critical, we really should be focusing our minds on the materials that we're specifying when we're commissioning our buildings or designing our buildings. If we look at the same house but make it twice the size, suddenly that initial impact is obviously twice as large. The impact of a gas boiler, you're going up at a rate double the rate over the next 15 years. And it's just to highlight that these metrics are per meter squared, but you also need to think about the total impact. That the bigger the building, the more material you use to build it, the bigger the carbon footprint. The bigger the building, the more energy you use overall to heat it, the bigger the impact over time. And then this last grey line is a sort of just to illustrate if you built a building twice the size or that just had twice the carbon footprint and then had it at building regs, you're off the charts within the first 5 years. So in summary, I guess what I'm sort of trying to highlight with this presentation is that we need to look at all three things. We need to look at the relationship between operational demand of the building, the embodied carbon, the materials we choose to build that building out of, and the fuel source that we specify. Also, just to remind everyone that the early decisions that you make can have long-reaching impacts. I think what I've come to learn as working in this industry for 15, 20 years, is that once you made a decision, you become quite attached to it. It's quite hard to let go of that decision. So, if you decide that you want a masonry house early on, then it's quite hard to go back from that. So think about the some of these things early on to avoid having to sort of detach yourselves from those decisions later. The RIB 2030 Climate Challenge points quite clearly towards Passivhaus, if not just the Passivhaus standard, but certainly Passivhaus principles and low carbon fuels for operational energy use As you saw with the example of our passive house in the New Forest, which is just 7 kilowatt hours of space heat demand, with a classic gas system, we're not quite meeting the challenge. So we really do need to get operational energy use down and then look at renewables. The other thing it's pointing towards quite clearly, the Committee for Climate Change are also pointing towards that, is low carbon materials and construction. And the Committee on Climate Change have gone further and quite clearly identified timber as key to delivering net zero housing to meet the 2030 targets and to increase the net carbon storage in the UK. The next three are just sort of slightly outside the presentation, but general tips. Use PHPP early to determine your energy use. If anything, if becoming a passive house designer has taught me anything, and also doing this embodied energy calculations taught me anything, is that you can make assumptions, and often those assumptions aren't right. Before we did the embodied energy study on our New Forest project, we thought we would be well in. We were quite surprised to see that we were only just getting there, or even failing without PV. Default to low carbon materials, obviously, as much as you can. If you can get hold of the pH ribbon to test the embodied carbon and look at different options, then that's great. It's really a very easy and quick tool to sort of focus the mind on the embodied carbon impact of your decisions. And then obviously default to low carbon fuels. Electricity is decreasing in carbon intensity and will continue to do so over the next decade, hopefully, unless we change our energy mix again. Gas is fixed. So back to our wheel, and I've sort of adjusted the wheel to show operational energy, embodied materials and fuel source are sort of equal. They're all equal because they're all kind of interrelated, and it's the relationship or the interplay between those three that is key to not only getting a sustainable building, but also to meeting the RIBA 2030 challenge. And that is it. So open it up to questions. Oh, now I can see the chat.
Thank you very much, Anna. So we've actually had quite a lot of questions come through. So if you're happy, I can read out a few of them, as we've actually got about sort of 10 minutes or so left, really. So the first one is from Rupert, and he's asked, if the majority of construction moves to timber frame to meet embodied carbon targets, how can we provide enough timber from sustainably managed sources, i.e. they're often shipped halfway across the world with consequent carbon emissions?
Yeah, so that's a good question. Those carbon emissions should be factored into your calculations, so they come under I think it's A4 in transport, and I think you need to think about where you're specifying your timber from, and you want to be specifying them from sustainable sources, preferably not too far away. The reality is we're building, we're going to be building, and if the choice is you measure the impact of a timber frame and you factor in the transport, and I would be surprised if you get lower than concrete or masonry, even with those things factored in, assuming that you've picked something that's sourced not too far away and that's being sustainably produced.
Great, thank you. And the next question is from Lucinda, and she's asked, do the calculations for locking up carbon in timber buildings assume a constant climate warming potential with time? Could it be more important to lock in carbon for the next critical period of 100 years or so than further in the future to flatten the emissions curve? So
yeah, I don't think the so whole life carbon modelling as an industry has grown massively in the last 5 years, and as far as I'm aware, that they are assuming a steady. Yeah, you're assuming a steady amount of carbon is per year that material is within the building over the life of the building, and then that's released at the end. So you sort of offset the saving and the release. But yeah, the next 10 years are critical, and what I was trying to show with those graphs at the end is that if you build a building that's has very, very low operational use and entirely off renewables, but has a very, very high embodied carbon, that embodied carbon is going into the atmosphere. Well, actually will have already gone into the atmosphere now or this year, and by the time the materials get to your site. And that's associated with your building. And if the next 10 years are the 10 critical years, then yes, I would say those do carry a great weight in terms of the impact of your building, if that makes sense.
Thank you. So the next question is there a monetary value for operational carbon, and does this indicate that expensive heating technology, for example, heat pumps, are economic?
Do they mean in the pH ribbon?
They haven't actually said, I'm afraid, Anna.
Okay, so not that I'm aware of. I haven't. If there is a cost tab in pH ribbon, but I don't know if it factors in are they talking upfront cost or the cost of operational cost?
I'm not too sure, I'm afraid.
So
just read the question.
well, I mean, one thing is to say that obviously air source heat pumps and ground source heat pumps, which are even more expensive, they become more economical when you can use them for more stuff. You can only use them for more stuff. You have a building that performs very well, otherwise you're not going to meet your energy demand. I know that there's going to be a drive in the industry. I'm not an expert on air source heat pumps, but I know from having read various documents there's going to be a drive to increase the air source heat pump market. So I wouldn't, current economic chaos aside, the idea is to bring the price down of those kind of technologies.
Next question, Gary has asked, what difference would hydrogen gas boilers have compared with current gas boilers?
So I'm afraid I don't really know very much about hydrogen gas boilers. I know that they're sort of looking at hydrogen gas as a potential replacement for regular gas that we use in our boilers, but I think the point of that is that we have we're not going to be we obviously the 2030 challenge is looking at new buildings. The 2050 target is all buildings. The majority of buildings in 2050 have already been built, and the majority of those buildings are not low energy buildings, and their space heat demand, their energy demand is unlikely to be able to be met by electricity because it's too high and the grid can't cope. So we need to look at a broad energy mix, and the majority of those buildings, if we're looking at houses, are obviously already set up for receiving gas. So I think the idea is to replace that with something else that has a lower carbon footprint, because the infrastructure is already there, and we need to look at ways of meeting the energy demand of those buildings.
Okay, so Rob has asked, I'm looking at a timber frame, timber clad wood fibre insulated home. How would this perform with Passivhaus's standards?
So he's looking at, don't want to sound like I'm advertising, but the product that we produce is a timber framed, timber insulated, timber clad product. It can perform to the Passivhaus standard. You just need to make the walls thick enough, and think about the airtightness and the windows and the MVHL. So building performance is about the amount of material that it's about the material, how the material performs, and then the thickness of your walls. You can absolutely achieve timber frame Passivhaus. The example I showed is I studs with cellulose, which is effectively newspaper insulation and wood fibre insulation on the outside, and that's wall U values of 0.1. So yeah, it's hitting Passivhaus standards.
Okay. Thank you, Anna. So I think the last question we've got time for is from Andrew, and it's a slightly easier question, I think. And it's, do they have open days when we're allowed to go out again to the New Forest home? It's very close to us, and I'd love to take a look.
Yes, so they participated in the Passivhaus. Passivhaus Trust runs Passivhaus Open Days. It's a little bit like Open House, which is an annual event as part of the Design Week. So that's normally, I think that's in the autumn. I don't know if it's happening this year, and I don't know if they're participating this year, but if they are participating, it will certainly be on the Passivhaus Trust website when that event comes around.
Fantastic. Well, thank you very much, Anna. It's brilliant, great presentation. Thank you very much for taking so many questions at the end. I'd like to say thank you very much to everyone for joining this session. And if you'd like to watch this session back, we will be sending out a recording of all the sessions today. So just keep an eye out for an email from us, and you'll be able to access all of them. So the next session is from 12 until 12:45, and this is called How to Get the Best Performance and Value from Windows and Doors. And this will be presented by Paul Smith from the Green Building Store. Thank you very much, everyone.
Thank you.